Good. So, what is an orifice? Okay? So, an orifice is used to measure the flow rate of a fluid. It is a small hole or simply an opening on the side or the bottom of a fluid vessel. It has many cross-sectional areas. Okay? So, these cross-sectional areas are, it can be rectangular, circular, or triangular. That's the definition of an orifice. What type of orifices are there? Okay? So, the classification of an orifice, classification of orifices, they can be based on A, size, B, shape, C, the age of the orifice, and D is the nature of the discharge. So on size we have two. There is a small orifice or a large orifice, and the formulas are different. So when you are reading a question, you need to pay attention. Is the question stating that it is a small orifice or a large orifice? Then also the shape which you have already stated can be circular, rectangular, or triangular. So you can have a small circular, or a small rectangular, or a small triangular, or large circular, large rectangular, large triangular. And depending on the shape again, the formula is again different. Then on the edge, two descriptions only available due to age. Is it sharp or bell mounted? Is it a sharp orifice or a bell mounted? This will only determine the coefficient of discharge. Okay? Then the final classification, is it a free discharge or it is drowned? Drowned. So what do we mean by free discharge? Is it open to air like this? Okay, this side there is only air, is open to air. Or it is discharging into another fluid. It is coming out, but there's a fluid on top and also there's a fluid down. Are we together? So, if it is open to air, it will be called the free discharge. If it is submerged, it shall be called what? Drowned. And all these terms may be used in the question. So it is very important to know which type of orifice we are talking about. In case the people are wondering what I'm drinking, this is what I'm drinking.
Coca-Cola.
Friday, so people may be wondering. So, with this definition, we can now go to the question. Okay? So the question says, a rectangular orifice 1.5 meters wide and 1.2 meters deep is filled in one side of a large tank. The water level on one side of the orifice is 2 meters above the top of the edge of the orifice. The water level is 0.4 meters below the top edge of the orifice. Calculate the discharge through the orifice if the coefficient of discharge is 0.62. Good. So we have an orifice here. So here, this orifice is 1.5 meters in width. And the height is 1.2 meters. Okay? Which means that, and then we have water. On one side of the orifice, the water is 2 meters. Okay? So on one side, the water is 2 meters. On the other side, the water is what? 0.4 meters. So what it is, gentlemen, here, there are two orifices in one. Why? Because where it is 2 meters, it shall be called a drowned orifice. Where it is 0.4, it means the other part is open to air. This is the free part. So even in our calculation, we are going to calculate the discharge for the drowned part and the discharge for the free part. So in this orifice, there are two questions put together. Very, very important. Let's go. Let's go into the calculation. Okay? So, data given. People are very good at writing data. Unfortunately, some people, they can just copy the data, apple and open. So, we have the width, B, width is denoted by B, 1.5. And then depth of the orifice, denoted by D, 1.2. Okay? Then we have height of water from top edge of orifice. That one is noted by H1, which is equal to 2 meters. Then difference of water level. Difference of water level. The other side there's a lot of water, the other side there's less water. So we have the 2 meters part, and there's another part where it is 0.4. So that is our H, which is 2 plus 0.4. So our H will be 2.4. Okay? So remember, there is H1 and there's also H. That description is very important. Okay? Then we also need to get our H2, which is the height of water from the bottom edge, which is H2. Okay? And H2 will always be given as H1 plus D. Okay? Which is the depth. So in this case, our H2 shall be 2 plus 1.2. 3.2. So, gentlemen, these values H1 equal to 2, H equal to 2.4, and H2 equal to 3.2. They are very, very important in our calculation. And the last value is CD, coefficient of discharge, which is given as 0.62. And of course, G, 9.81. With all those parameters, okay, we can now get our discharge. Okay, so discharge QT, total discharge, will be equal to Q1 plus Q2, where this is our total discharge given by discharge due to partially submerged, which is free air. Partially submerged, because one part is partially submerged where the height is less than, where the depth of the water is less than the height of the orifice, and Q2 where it is free to air. The other part is submerged. So we are going to have Q1 discharge partially submerged and Q2 free submerged. It doesn't matter which one is your Q1, which one is your Q2. But what is important is to know that there is a part which is submerged and there is a part which is not submerged. So I'll start with Q1. And the formula is given by the coefficient of discharge multiplied by the breadth, which is the width, open bracket, H2 minus H, close bracket, the root of 2GH. That's the formula. So, your description of H2 and H is very, very important. So we know 0.62 multiplied by the breadth, which is the width, 1.5. H2 we calculated, it was 3.2 minus H, 2.4 multiplied by 2 times 9.81 multiplied by H, which is 2.4. That is how we calculate the discharge through a partially submerged orifice, which is a drawn orifice under the description of discharge. Under the description, we can classify an orifice on discharge as free to air or submerged. So when it is submerged or drawn, that is the formula. This part is well known. The 2GH. C, D, and B are not a problem. The issue is this description here. That is all. Okay, let me get my calculator. I do the partizo. Anyone punching?
We are punching.
Yes.
Yes. 5.105.
Correct. Thank you. 5.105. What are the units? What are the units for discharge? What are the units for discharge?
Meters, cubic meters per second.
meter cubed per second. Okay, and that's how you will be posting the results on Facebook. Hello? Can we proceed?
Yes.
Hello.
Good. What about the portion which is free? Q2. What is the formula for Q2? I'm going to put it like this. First, let us put Q1, which is CDB H2 minus H. Close. Okay? Then 2GH. For fluid to air, the formula is the same. No, it's not the same, it's similar. The first thing is that it has a fraction in front. Two things. CD, B. Then this H we subtract here comes at the end. It has 2G. Just like that, 2G. Okay? Multiplied by.
Able to see the picture.
You can't see the picture.
There is someone among the group. I think I've seen the text that the screen is dark. I can't see anything.
But you are able to see.
Yes, I'm able to see is Mr. Joe Chama.
So Mr. it means it is the settings of his phone. Tell him to join with video. Okay, let us proceed. The minutes are running out for this question. Let's finish. We will send him the video. The video will have the pictures. Let him change the settings. Okay, so the H now, here, we put it in brackets. It's no longer H2 minus H. It is now H minus H1. But this H inside has got a power. And the power is the reciprocal of this value here. This value is 2/3. Then the power here is the reciprocal of this value here. So the power is what? 3/2. And even here, 3/2. They have the same powers, and that is how we are able to do what? To subtract, because their quantities are equal. Okay? So, with this formula in place, we can put our values, 2/3. Our CD is 0.62, our B 1.5, 2 multiplied by 9.81. Then we have our H, which was 2.4. to the power 1.5. I hope you know that Q over 2 is the same as 1.5 minus H1, which is 2 to the power 1.5. We calculate 2 divided by 3 multiplied by 0.62 multiplied by 1.5 multiplied by the square root of 2 times 9.81. We get 1.8308. 8308 multiplied by, we patch that one, 2.4 to the power 1.5 minus 2 to the power 1.5. 0. Let me patch again. I think I did patch properly. 2 divided by 3 times 0.62 multiplied by the square root of 2 times 9.81. 1.8308, okay? 2.4 to the power 1.5. Get that one. Minus 2 to the power 1.5. Okay, 0.8896. Correct. Can somebody confirm my calculation? I'm getting 1.6287. Can somebody confirm my calculation? Hello?
Doing the punch chisel.
Yeah.
Yeah?
Yes, that's the answer.
Thank you. So
That's the answer. Yes.
our Q total will be 5.103 plus 1.6287.
The camera is not clear at the bottom.
Okay, I see. Yeah. No, I can see.
No, I can see. Let's mute our mics.
So that's the total. So we have run out of minutes, so it will end and then I will immediately do another link, okay? So that we continue solving.